Hi, everyone. I just wanted to record a quick video because in the video of section 3.1, in my example for using completing the square to find the standard form of a quadratic function, I made a very silly mistake in the algebra, and it kind of messed up the whole example, and I totally did not catch it when I was doing it. So I'm going to do the example correctly, and I'm going to do another example to kind of really clear the air and really show you how to do these computations to find the standard form of a quadratic function. So this will be a better explanation for completing the square. Okay, so completing the square actually is just like a special application of the perfect square formulas. So recall these formulas, we saw them all the way back in chapter 1. They kind of looked like this. You had an a squared plus 2ab plus b squared. That equals a plus b all squared. And we also had a similar one where we had a minus instead of a plus on that second term. And that's equal to a minus b all squared. So if you don't remember these, I recommend you go back to the chapter 1 material and refresh yourself a bit, because these are the formulas where completing the square comes from. And in fact, in the original 3.1 video, this is sort of the math, the logic, where the b over 2 squared comes from. So I also just wanted to give you a little bit of background on that. Like, this all works because of the way the perfect square formulas look. They let us do this thing, which is really nice. So let's look at that example, this time done correctly. So let's redo this. So we have f of x, and in that video we had 3x squared minus 12x plus 6. And so first off, I'm going to group first two terms together. Oops, sorry. Getting a little ahead of myself. That should be a 12x plus 6. And then, as with last time, I'm going to take that leading coefficient and I'm going to pull it out of that parentheses. So we get a 3 on the outside, and then x squared minus, and then because we pulled a 3 out from this term too, because that's how factoring works, 12 divided by 3 is 4. And then plus 6 out here. And then we're going to do that add and subtract kind of thing that we did last time. So we have a 3 still outside, x squared minus 4x plus, all right, and then the b for this thing here, the b is negative 4. So we get negative 4 on the top over 2 all squared. And that's going to be plus 6 minus, and that's going to be this leading number here, 3 times this thing here. So we're subtracting that away. And we're doing that to make sure that we can still say that this is equal. We're adding and subtracting the same thing to it, so it's still equal. Okay, and now we can apply our fancy formula to the thing inside the parentheses, and we get x minus 4 over 2 all squared. And then the same riffraff on the outside, the plus 6 minus 3 all times negative 4 over 2 squared. And now we can simplify. So now 4 over 2 is just 2. So we get x minus 2 all squared there times 3 plus 6 minus 3, and then that's going to be a negative 2 squared. And then we get a 3 again, same thing over here, plus 6 minus 3 times -2 squared. That's -2 times -2. That's going to be +4. And then simplifying some more, 3 times 4 is 12. So we get 6 minus 12. And then last step here, we get 3 all times x minus 2 squared minus 6. And that is standard form. And then you can also check using a calculator or whatever you want. You can check that the vertex for this is indeed what we want, 2, -6. Okay, just to make sure that we're all squared away and we're solid on this kind of stuff, because this is important, let's do one more example. Let's look at f of x equals x squared. Let's do plus 6x, and then we'll do plus 13. Okay, so first things first, let's look at those first two terms together. Group them with some parentheses, just so we can laser focus in on them. And then usually I would pull out the leading coefficient of the x squared here, but since that's just 1, we don't need to do that at all. So we're good to go. So then we can go ahead right into the adding and subtracting step. So for this thing here, the b is +6. So when we go ahead and do this step, we're going to do plus 6x plus 6 over 2 all squared plus 13. And then, of course, we have to subtract away. The leading number, again, is just a simple 1. So it doesn't really change anything. But we can put a 1 there just so we can kind of keep track of what's going on. 1 times then this thing here, which is 6 over 2 all squared. So now we're adding and subtracting the same thing. So equals is good to go. So now we can apply our formula to the thing in parentheses, and we get an x plus 6 over 2 all squared. And then the same riffraff on the outside, plus 13 minus 6 over 2 all squared. Okay, now it's just simplifying again. So x plus 6 over 2 squared plus 13 minus, I guess I should simplify 6 over 2 to actually be 3. 6 divided by 2 is 3. And then over here we get a 3 squared as well. And so we get x plus 3 squared plus 13 minus 3 times 3 is 9. And then one last step, we get x plus 3 squared plus 4. And that is the standard form we want. So hopefully this clarifies things. But of course, if you're still confused, I'm more than happy to answer questions. Just shoot me an email or pop by office hours.